The next operation of the circular linked list is deletion. So here also two cases for doing the deletion operation in a circular linked list. One is deleting the first node. Okay, deleting the first node. Then second case is deleting the last node. So these are the two cases. So first we will see about deleting the first node of the circular linked list. Okay, so consider this is a circular linked list we have taken. So here what we have to do, we have to delete the first node. So here also we are using same condition what we have used in the insertion, that is ptr tends to next is not equal to start. So this condition, that is a while loop we are using here. So till this condition becoming false, what we will do, we will execute the statement. Okay, so if this condition is true means what we will do means we will execute the statement ptr is equal to ptr tends to next. If condition is true means we will execute this loop. Okay, so here when you are doing the deletion at the starting, what will happen, this node will be removed by using the free function. By using the free function, this node will be removed, and the second node will become as a start node, and this node contains the address of this second node. Okay, contains the address of this second node. We will see the code for this. So this is the code for deleting the node from the beginning. Okay, so first we are declaring one variable, that is a ptr variable, and what we are doing, we are in the next statement we have to assign ptr is equal to start. So what will happen, this is a start node, it will become as a ptr. Then we have to check the condition ptr tends to next is not equal to start. Okay, we have to check the condition ptr tends to next is not equal to start. If this condition is true means it will execute the statement, that is ptr is equal to ptr tends to next. It is same as the previous code what we have seen. Okay, so we will check this. First we are checking ptr tends to next is start. It is not a start node. So what will happen? You have to execute this statement. So what will happen? This node become as a ptr node. Again we are checking ptr tends to next is start. No. Then next ptr tends to next is start. No. Then next ptr tends to next is start. No. Then next node ptr tends to next is start. No. Then ptr tends to next is start. No. Then next node ptr tends to next is start. This condition is true. So what will happen, this condition is false. So what will happen, if we will come out of the loop and we will go to this statement, what we will do, ptr tends to next is equal to start tends to next. So ptr tends to next, this is a ptr node, and what is the next node, ptr tends to next. So it is given ptr tends to next, it should be start tends to next. What is the start node? This is the start node. So what is the next node of the start node? This. So what happened? It contains the address of the start tends to next. Then what we will do, by using the free function, we will remove this, and what we will do, ptr, this is a ptr node, right? This node's next node. What is the next node? This is the next node. So it will become as a start. Okay, so repeat once again, I will say. So we are checking this while loop, and by using this loop, what we are doing, we are finding the ptr tends to next node. After finding this, finding the next node, ptr tends to next should be a start node. For that only we are checking this condition. Okay, so after finding this particular after checking this condition, and once this condition becomes false, we have to execute this statement. So ptr tends to next. So what should be a ptr tends to next? So ptr tends to next means what should be here? Okay, what should be here? That is start tends to next. So what is the start node? This is the start node, and this is the next node. So this node's address path should be saved here. So for example, the address path is 100 means, so the 100 will be stored here. Then next, by using the free function, what we are doing, we are removing this node. Then start is equal to ptr tends to next. So what is should be a start node? ptr tends to next. So this should be a start node. Okay. and algorithm and the code. So this is the algorithm for the deletion of node at the beginning. So here, for when you are doing the deletion, we have to check the underflow condition. Then what we are doing, you can compare, it is same. So first what we are assigning ptr is equal to start. Then we are checking the condition, ptr tends to next is not equal to start. If condition is true, means we have to execute the step ptr is equal to ptr tends to next. So same thing. Then if it is the end of the loop, once it becomes false, we have to execute the statement ptr tends to next is equal to start tends to next. So same, ptr tends to next is start tends to next. Then by using the free function, what we are doing, we are removing the start. Then next start is equal to ptr tends to next. So the same time, then we have to return the start. So this is the code and the algorithm for deleting the new node at the beginning.